بسم الله والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أهلا وسهلا بكم في آخر ليالي السبرانية المقدمة لكم من الاتحاد السعودي للأمن السبراني والبرمجة والدرونز بالشراكة مع شريك الممكن الرقمي STC. خلال 15 الليلة الماضية تشرفنا بأن نستضيف لكم متحدثين كثر في مجال أمن المعلومات والأمن السبراني ودورات تدريبية كذلك، ومن خلال هذه الليلة السبرانية دعوناكم للمشاركة في المسابقتين التي تأتي تزامناً مع هذه الليلة السبرانية. اليوم وقبل المحاضرة الأخيرة ندعوكم كذلك للمشاركة في هذه المسابقتين. المسابقة الأولى مسابقة أفضل ثريد مستقل عن كل ما تعلمته في كل محاضرة من الليالي السبرانية باستخدام هاشتاج سايبر نايت. اليوم آخر فرصة للمشاركة في هذه المسابقة وعليها 3 جوائز بإذن الله. وكذلك ندعوكم للمشاركة في مسابقة الاختبار الشامل اللي نزلنا عنه معلومات عبر حسابنا في الاتحاد في تويتر. فعلوا التنبيهات في حساب الاتحاد عشان تعرفون التفاصيل اللي راح تصير خلال الساعات القادمة بإذن الله، كيفية المشاركة في هذه المسابقة وكيفية الفوز كذلك. اليوم في محاضرتنا الأخيرة نسعد باستضافة الأستاذ نيكل ماتال من بنتستر أكاديمي، راح يكلمنا في محاضرة بعنوان Attacking and Defending Active Directory for Red Blue Teams. هذه المحاضرة راح تكون باللغة الإنجليزية، بس كما عودناكم راح ننزل بإذن الله ترجمة لأهم ما حدث في هذه المحاضرة عبر حسابنا في تويتر، ويتبعها ترجمة لاحقة بإذن الله عبر حسابنا في اليوتيوب لكل المحتوى باللغة العربية كذلك. مشاهدة ممتعة لكم. مستر نيكل ماتال، the mic is yours.
Thank you so much. Hi everyone. So let's start with the session for attacking and defending Active Directory. Let me share my screen once. Okay, so I'm going to talk about how we can attack, how we can execute common attacks against Active Directory and what are the defenses against those attacks. I'm going to have demonstrations as well in between the sessions, so that those of you who really want to look how attacks are executed can have a look at that, right? So I'm with Pentester Academy. We are an online cybersecurity education providers. We have more than 40 online courses, video courses. There are more than 1,700 online labs. We do not have restrictions on any lab time. All of our trainers are Black Hat DEF CON speakers. We also have cyber ranges based on Active Directory. And in fact, I'm going to use one of the cyber ranges, which you can find under the Red Team Labs section here. I'm going to use one of that in this workshop, right? You can find me on Twitter as Nikhil_MITT. If you would like to use the lab which I'm going to use in this workshop, you can go to this link and register, and we will send you the access to the lab. It would be a limited access, but we will share the lab access with you so that you can practice whatever I am doing in this on this workshop. You can try it on your own. You can find my blog at labofopenetrationtester.com. I maintain few open source toolkits for penetration testers and red teamers like Nishang, Deploy Deception, and Trace Toolkit. I'm usually interested in offensive information security, new attack vectors, and methodologies to pawn the different machines, systems, or on Active Directory networks. I have previously spoken multiple times at DEF CON, at Black Hat USA, Europe, and other versions. I'm a regular speaker and trainer at BrewCon and many more conferences. So what we are going to discuss in this workshop is I'll briefly introduce you to Active Directory, those of you who are not very familiar with it. A very quick introduction what Active Directory is. Then we will have a look at the attack methodology. What is the methodology which we are going to use? Then we start with different phases of attack in our lab. We'll go for port scanning and enumeration. We'll try to discover different machines in the network. Once we have compromised at least one machine, then we'll go for domain enumeration. After domain enumeration, we'll see how we can extract credentials from a Windows machine, right? We'll see different methods of them. We'll practice some of them. Then after extracting the credentials, we'll have a look at how we can spray or test those credentials out in an Active Directory environment. Then application whitelisting and SQL Server attacks, these two items we will cover if we have enough time. So I've included them because those are part of the labs. So that would be the bonus content. From credential spraying, if we do not have, we run out of time, then we'll jump to the domain privilege escalation part. And finally, how we can persist our domain admin privileges in the target environment. So that is going to be the agenda, right? Please keep in mind that we will assume that we already have internal network access, not to a Windows machine, but we have access, that is, we are in the same network as the target environment. And we are not going to use any exploit at all in the class or in the workshop. But what we will do is we'll depend on abuse of functionality and features, because that is something which is very rarely patched. So if you learn or understand something from this workshop, it will have a very long shelf life, at least for 5 to 7 years. Why? Because we are using fully patched Server 2019 VMs in the lab. So anything which we discuss here is not going to be patched soon or at all, right? Please note that the techniques which I'm going to discuss can be executed using different tools. Some of them could be from a Linux box or a Windows box. But for the sake of time and understanding, we are going to use the easiest ones, right? So let's start. Let's start with a basic look at Active Directory. So what is Active Directory? As the name suggests, it is a directory service used to manage Windows networks. Now, Active Directory stores information about objects on the network and makes it easily available to users and admins. Everything in Active Directory is considered an object, whether it be a user, a computer, a network, a trust. Everything is considered an object, and every object has its own properties. Now, the textbook definition of Active Directory is: Active Directory enables centralized, secure management of an entire network, which might span a building, a city, or multiple locations throughout the world. So what does that mean? From this, we can understand that an Active Directory network has different objects, let's say a user object, a server object, a Windows server object, a Windows client object, and so on, right? Now, each object has its own set of attributes or properties. For example, a Windows user may have account information, privileges, profiles, policies. A Windows server may have network information, file shares, policies, etc. Now, what Active Directory does for all of these components, and these components could be on a physically different locations, Active Directory provides manageability, security, and interoperability between all of these different objects. That is what Active Directory is. That is, as a very simple example, Active Directory allows a Windows user to access, let's say, a Windows client or a Windows server securely and anywhere in the entire network, which is under that particular Active Directory environment, right? So this is what Active Directory does. Once again, it provides easy manageability, security, and interoperability between different types of objects. And the objects could be user, machines, and other things, right? Now, there are four types of components or base components of Active Directory. One is schema. So in this diagram, if we go back here, I said that this Windows user has some attributes. Now, what decides the objects and their attributes. It is the schema which defines objects and their attributes. That is, let's say a username would have, let's say, a first name and a last name, but a machine may not have that. So that is defined in schema. Then there is query and index mechanism. It provides searching and publication of objects and their properties. Because an Active Directory environment could be spread across different locations, a query and index mechanism allows it to be searchable by different users and objects. Now, where are these properties stored, or where are the addresses of these, the locations of these objects are stored? That's in the global catalog, which contains information about every object in the directory. So let's say you want to search for a user. When you go to the UI or use any built-in tool and search for it, your machine goes ahead and looks for the global catalog. Every domain controller in a forest has a copy of the GC for the global catalog. Now, because every domain controller has the copy of the global catalog, there must be a method so that they can remain in synchronization, they can remain in sync. And for that, there is a replication service which distributes information across domain controllers, right? So these are the 4 basic components of Active Directory. Now, this is the basic structure of an Active Directory environment. Please always keep in mind that when you hear the word Active Directory, think of it as a forest, not the domain, right? A forest, which is considered a security boundary by Microsoft, a domain is not considered a security boundary. A forest may have multiple domains. It will have at least one domain, which would be the forest root domain. Other than that, there could be multiple domains. Every domain may have multiple organizational units. Organizational units need not be separately different or need not be separate departments. Organization units are those units where you apply your group policies, right? So an organization unit may have a certain set of policies applied to it. So this is the basic structure of Active Directory. So that would be all about the introduction. Now, what is the methodology which we are going to use? So I love this particular methodology. I keep reusing it, the assume breach methodology, which is used by Microsoft's Cloud Red team. So what they suggest is, in place of the traditional trench-based security or the perimeter-based security, where you assume that an attacker is going to break into the DMZ or the perimeter or the security perimeter, in place of that, in case of assume breach, we assume that our network has already been breached and the adversary or attacker is already inside the network, but we have not discovered it yet. So I take this quote from the assume breach methodology white paper. It is more likely that an organization has already been compromised, but just has not discovered it yet. So assume breach works on that particular philosophy. So we are going to have a look at a lot of insiders attack simulation in the workshop, right? We are going to follow these phases of our attack. We are going to run port scanning for recon, some domain enumeration, a bit of local privilege escalation if required. Then we'll continue our recon using those new privileges if required. Then lateral movement using the privileges which we gather in these steps. We laterally move to other machines. Then we escalate our domain, our privileges to domain admin. I will not have a look at cross-trust attacks. That would be out of scope for this particular workshop. So after domain admin privs, we'll jump to persistence, and of course not exfiltration, but persistence part. That is, how do we persist with our domain admin privileges? So that is all which we are going to have a look at. The lab environment where I'm going to demonstrate to you is this. Once again, that if you want to try the lab out, you can sign up here. The lab contains 6 target machines. all of which are fully patched Server 2019 machines with updated Windows Defender. And the forest functional level is Server 2016, which also is most up to date. There is no Server 2019 forest functional level, right? So we'll access the lab using web browser. There is no need to connect to any VPN, etc. So we'll land on a student machine, which is the Linux machine. And then from there, we will try to compromise certain machines. Once again, as I said, that some of the machines we will visit only if we have enough time, right? But we'll cover all the interesting topics. Do not worry about that, right? So that's going to be our lab environment. So let's start. We're going to start with port scanning and enumeration. As you can see here, we are landing on a Linux machine here. So we will start with port scanning, and we'll try to identify if there are any live machines. Of course, there will be, and what are the open ports on them. And of course, we are going to use Nmap for that. So Nmap is, of course, if you go to nmap.org, you will get to know more about it. That's the most popular port scanning tool, or one of the most popular security testing tools which you will find. Now, there are many interesting Nmap flags which can be used. We are going to use a full connect scan, which is ST. If you go for -SS, this would be a bit more clear once I show you the command, but let's go through this nonetheless. SS is for half connect TCP scan. So a full connect scan is more reliable, but it is slower because it completes the TCP handshake. The SS, or the half connect scan, does not complete the handshake, so it is faster but a bit less reliable. SU is for UDP scan. SV is for service detection. So of course it takes a lot more time. It's a bit more aggressive, but you can get banners and versions of services running on the network on a remote machine using this one. -O is for operating system detection. And finally, SC for default scripts to check for vulnerabilities. Now, there are a lot more options in Nmap, but these are some of the more interesting flags, right? So let's start. Okay, in a moment. So let's go for MSF first then. So this is port scanning using Nmap. Now, once we have identified Windows machines, which we'll do in a moment, then we can go ahead with other interesting enumeration techniques. One of the techniques which we are going to have a look at, and which I have personally seen in a lot of environments, is open shares, open file shares or SMB shares, right? So we are going to enumerate for open shares on the machines which are reachable from our attacking machine, and we will have a look at if we have write permissions or any interesting permission on any of the open shares. We will use Metasploit framework, another very popular tool, and another open source tool for enumeration of open network shares, open SMB shares, right? If you are not familiar with the Metasploit or MSF, it is an enumeration and attack framework. MSF contains different types of modules like auxiliary, exploit, payload, host modules, etc. Auxiliary modules are used for enumeration, scanning, recon, info gathering, fuzzing, etc. That is to not execute a payload, just to gather information or just to check availability of a service, right? You can, once you started MSF console, you can use show auxiliary command to list all the auxiliary modules. Then there are exploit modules. Now these modules are used for exploiting a specific vulnerability, right? These are the modules which provide you access to a target machine, right? You can run show exploits command to list all the exploit modules in your Metasploit. And then there are payloads. Now, a payload is the code which executes on the target on successful exploitation. So, for example, let's say you abuse the eternal blue vulnerability. I'm just using it as an example. I'm no fan of patchable vulnerabilities. So let's say you want to abuse the popular eternal blue vulnerability, or you want to exploit it. So what would you like to do after exploiting it. Let's say, as a very simple example, let's say you want to add a user to the target machine. So the command which you will use to add the user to the target machine, that is what the payload is. So the popular payloads are, of course, reverse shells, that is pieces of code or payload which connects back to your machine. Why those are popular? Because that is usually allowed across firewalls. Firewalls are more strict for inbound traffic than outbound traffic. That is why payloads like reverse shells are really popular. You can use show payloads to list all the payloads in your Metasploit, right? So let's have a look at our first demonstration. What we have done up to now, we had a very quick look at what Active Directory looks like. Then we saw that we are going to land on a Linux machine in our target lab environment. And first we are going to use Nmap to identify live machines, right? So let's get started. This is our attacking machine, right? And please keep in mind that most of the times I'm going to copy and paste the commands for two reasons. One, I don't want to spend time figuring out what typo I made. Second, I use a mechanical keyboard, so I don't want my keystrokes to distract anyone, right? So let's run a simple scan. I'm not going to spend a lot of time on the port scanning part, but let's have a look at it in any case. So we are going to run the nmap command. I think I have to copy it again. So what I'm doing here is I'm calling nmap with the SS option, which we discussed, which means a half connect scan. I don't want a name resolution. I want double the verbosity. And I'm using the T4 template, which is the second fastest. T5 is the fastest one, but it may, at least theoretically, crash at least some older machines. So it's not always safe to use T5. So let me run this. As you can see, we are automatically sending an ARP ping scan because we are looking for just the local network. Our attacking machine is 192.168.2.1. So this is us. Other than that, you can see that we find out a lot of machines, a machine called 2.254, 2.168. Most probably all of them Windows machines. Why? This is the RDP port, right? And the Mac belongs to Microsoft. So in all probability, these are Windows machines. Now, one very interesting thing which we are experimenting with in this particular lab is, as I said, this one is going to be a part of our Cyber Ranges offering. So what I'm experimenting with, we are experimenting with this one is actually this. We actually provide you access to all the victim machines as well, right? I'm looking at this as a practice lab, not a challenge lab. So this allows you to actually test out stuff, troubleshoot things. And if you want to have a look at what it looks like on the victim when someone abuses them using Metasploit, then you can use these connections to directly touch the victim machine, right? So once we are done with the port scan part, we identified some Windows machines, right? Now, once we have done that, now we are going to use Metasploit, which we can run with the command called msf console. Now we are going to use Metasploit to enumerate the open shares on the target machines, right? We are going to look for any world readable or writable shares on any of the machines. So once we've started Metasploit, I will load an auxiliary module. SMB enum shares. As the name suggests, this particular module enumerates shares for you. There are only certain required parameters. We are going to only populate them. Of course, our hosts, and if we have any username and password. We do not have any username and password. So what we are going to do, we are simply going to paste our command here for our host. So using our nmap scan, we identified these machines. I deliberately did not discuss it in much detail because we have a lot more interesting stuff to target or to check. But these are the machines which we find out are live on our network. If I run this enumeration auxiliary module right now, you will see that on all the machines other than this 2.21, there is no open share. But on 2.21, we have an admin dollar, a C dollar, an IPC dollar, and a share called files. Now, admin dollar, C dollar are special shares. If you find a machine in the network where admin dollar and C dollar are reachable without providing any credentials, then there are a lot, I mean, that's not default and that's very, very rare, right? So the point is we should go after this share because that's a non-standard share and probably is an actual misconfiguration in place of being a false positive from Metasploit. So let's go for this files share, right? So what we are going to do here, we are going to use the SMB client utility to try to connect to this particular one. So what we are doing, we are trying to connect to 192.168.2.21 and the share files, right? That is what we are trying here. This -n means we do not want to specify a password. So as you can see that we do have at least read access here. So let's go to the logs directory if we can find anything. No. Let's go to the maintenance directory. And in the maintenance directory, there is a file called cleanup.ps1. Let's check if we can actually access it. So what is our task here? One was to use nmap to identify live machines and TCP ports on them. Second is use Metasploit to enumerate open shares on any of the live machines in the network. We have found that out. The last one is check if we have write permissions on any share. So let's try that. So let's read this script. We can use the get command to download it, right? So what is this cleanup.ps1? It says it is a script to clear logs from C logs every 5 minutes, and then there is a PowerShell command. So now this is something where we have to actually take a decision, right? No tool will tell us what we need to do right now. So here is how we can connect the dots here. We found a PowerShell script in a directory called maintenance. The script is called cleanup.ps1, and it says that it is a script to clear logs from C logs every 5 minutes. So this clearly means, or at least hints, that this PowerShell script is probably executed by a scheduled task every 5 minutes, probably that, right? So how would we test that? First, we need to check if we have write privileges on that share, right? If we have write privileges on this share, we are going to modify this cleanup.ps1 and write it back on the share and wait for something to happen. So before we can actually check, let's simply create a file called hello.txt. And let's connect back to the share, go to the maintenance directory, and let's try to put hello.txt there. We can. So this was our final task of demo 1. That is, do we have write permissions on this particular share? right? So let's go back and we'll come back in the next demo. We'll try more stuff. Now, once we have identified a PowerShell script, which probably we can modify and which is probably run by a scheduled task. Now we need to generate a payload, right? Once again, remember a payload is the piece of code which is actually executed on the target. We are going to use the MSF Venom utility or tool from Metasploit for generating payloads. For our current scenario, we can use the following command. MSF Venom, that's the name of the tool. The payload -p, the payload we want to use a Windows x64 Meterpreter reverse TCP. A reverse TCP Meterpreter which connects back to us, which connects back to our attacking machine, right? The format -f, what is the format we want to use? That's PowerShell. PSH stands for PowerShell in this case. lhost, because it is a reverse shell, it connects back to us. We need to specify our lhost here. Which IP address do we want our reverse shell to connect to? It takes the default port of 4444, and we want to save this reverse shell in a file called payload.ps1, right? Once again, -p for specifying the payload, which is a Windows Meterpreter for 64-bit, a reverse TCP. There are so many types of Metasploits, right? Remember the show payloads command, etc. -f for format of the payload. We are using the PowerShell payload format. There are so many which MSF Venom supports. lhost. This is something we use for the IP we use for the reverse shell. That is where the payload will connect back to, and -o is path to the output file. Right. So when we run this, we get a payload.ps1, which is a Meterpreter reverse TCP in PowerShell format. Now, what is a Meterpreter? Those of you who have never used it, Meterpreter is the most popular payload in MSF, and it is interesting actually. I usually never ever use exploitation frameworks, even Metasploit, in my assessments or even in my classes, right? And in fact, I rarely use any Linux box. So this is very interesting even for me when I was creating this particular workshop slides, right? So coming back to this, Meterpreter is the most popularly used payload in MSF, right? Why it is very popular? It stays in memory and the communication is encrypted, and you can extend it. There are so many extensions which you can use, right? But because it is the most popular payload, therefore it is very heavily fingerprinted by antivirus, etc. And it is therefore detected very easily if default options are used. For example, even if our lab environment, we simply rename this payload.ps1 to cleanup.ps1 and upload it to the target machine, it gets detected as a virus, as a malicious program, right? Because like every other antivirus, Windows Defender has heavily fingerprinted the Meterpreter. So we have to bypass it or use non-default options. We are going to come to that in a minute. Now, once you have a Meterpreter session to a target machine, you can use the help command to list available options. There are so many interesting options. Some of the popular extensions which we are going to use, in fact, are Kiwi. Kiwi extension is for Mimikatz. Then PowerShell extension, Incognito extension. There are so many of them which are super useful, right? We can use the load and the name of the extension. For example, load Kiwi to load Mimikatz within the memory of the Meterpreter, right? Now, we are going to generate here. We generated a PowerShell payload with MSF Venom, right? Now, here's the thing with PowerShell. PowerShell was abused a lot by adversaries and attackers for so many years. So I think in 2014 or 15, Microsoft came out with PowerShell version 5. Now, PowerShell version 5 had many interesting changes when it comes to security of PowerShell. One of them, which I personally like, both like to bypass, is the anti-malware scan interface, or MZ. Now, what MZ does, so what MZ is intended for, it is to tackle abuse of Windows scripting languages by attackers, and also the macros. So MZ, as the popular knowledge is, it is not only recommended to PowerShell, but other scripting options as well, like VBS. And it also takes into account, recently it also has taken into account the macros, right? So in our case, if we use our PowerShell Meterpreter, it will be detected by Windows Defender, right? If we write it to the disk. Now, PowerShell allows us so many avenues of executing payloads from memory. So if we try to execute a payload from memory, a PowerShell payload from memory, AMSI or MZ steps in and leads to its, or results in its detection. How? AMSI has no detection logic of its own. What it does, it enables scanning and inspection of dynamic scripts using the antivirus on a machine. So you can think of it like that. Let's say you want to run a PowerShell payload. As soon as the payload is about to execute, MZ picks that payload up and throws it to the registered AV, which is Windows Defender in this case, and asks it to have a look at the payload, right? If there is a signature with Windows Defender for that particular payload, it will result in a detection, otherwise no detection, right? Now, because we are using a stock Metasploit payload, it will be detected. So we need to use an obfuscated MZ bypass before we use the payload to avoid detection, right? So let's jump to the next demo now. What we are going to do, we are going to generate a Meterpreter payload in PowerShell format. And once we have that, we are going to use that payload to get a Meterpreter session on 192.168.2.21, the machine where we identified the OpenShare, right? So let's go back here. So let's generate our Meterpreter here. So this is the command which we discussed in the slides. Let's generate a payload.ps1. Right, the payload is generated. One thing which I always find out when using PowerShell payloads of Meterpreter, sometimes they immediately exit. So you'll get a Meterpreter session and they exit. So it makes sense to do something like this actually. We open up, so those of you who are well versed with PowerShell will immediately identify that this is a PowerShell script. Now, to avoid immediate exit from this particular payload, what we are going to do, we are going to add a simple infinite loop at the end, right? A patch, but it works fine, right? So if we have a look at the last line here, that's our loop, right? Once we have that, let's have a look at our MZ bypass. So this is our MZ bypass, which is obfuscated because without obfuscation, it gets detected by Windows Defender, right? So finally, what we are going to do is this. Let me show you the command and then I'll explain that to you. What we are doing, we are writing to cleanup.ps1 locally. We want to first download and execute the MZ bypass. And then in the same PowerShell session, we want to download and execute our payload.ps1, right? So the command is IEX stands for invoke expression, which is a built-in PowerShell commandlet, which, as the name suggests, executes an expression. Then IWR is invoke web request, another built-in commandlet. We want to use basic parsing so that if Internet Explorer has never been used on the target machine, our payload still works, and then the URL to the payload. right? So this is what we can write inside our cleanup.ps1. Now, before we upload it to the target share, we need to start 2 listeners, or 1 listener and a web server. First thing is, because we want to serve these tools from a web server, we can actually start the Python simple HTTP server here. So our simple HTTP server is listening on port 8000. And in our Metasploit, we would like to start a listener. So what is the listener which we are going to use? We are going to use the exploit multi-handler. Let me paste all the commands and then I will explain that to you. So what we are using here, we are using the exploit multi-handler, which is a listener, right? Sorry. We are going to use exploit multi-handler, which is a listener. Now the listener needs a payload, that is, it needs to identify what type of payload will connect back to it. We use the Windows x64 Meterpreter reverse TCP, the same payload which we used with MSF Venom. Once again, alhost, it is the same alhost which we used with MSF Venom. And if we have a look at the options of this module, this multi-handler module right now, so the exit func by default is process. The L host we set to 2.1, and we are using the default L port, which is 4444, right? Now, using the exploit command, we run the exploit. And okay, so this is a remnant of my testing actually. So we found out that we have a Meterpreter session there, right? I actually wanted to show you that we put it how we use this put hello.txt there. Let me show you in any case, right? So that you get to understand what we actually did here. So using the SMB client utility, we connect back there. We go to the maintenance directory. And then we put cleanup.ps1 there, right? And once it is put, as we thought, as we proposed, the scheduled task runs it, right? And it downloads and executes our payloads, our ng bypass and the payload from memory. And therefore, we get a connect back from 2.21 to our current machine. So this is what the Meterpreter looks like, right? So we have the privileges of a user called file admin, right? Please keep one thing in mind. Those of you who, if you go ahead and sign up for the lab, I have slightly changed the lab for this workshop. Just minor differences, but enough to not give you a complete walkthrough right away, right? So that you get a bit of challenge if you want, right? So we get the privileges of file admin. So what we did here, we abused a writable share, uploaded or replaced the log cleanup script there, and put our Metasploit or Meterpreter payload there, right? So this actually means that why it is always recommended to have signed scripts, even if those are self-signed in your enterprise environment, right? This attack may not have happened if you were allowing only signed scripts. But that was our next task, right? We get a Meterpreter session on the target machine. So if we go here, if we run help here, for example, that provides us help of different post-exploitation or different tasks which you have here, right? If you want to execute a command, if you want to get some situational awareness, privs, processes, you want to revert the target machine, etc. There are so many things which you can actually play with once you have access using Meterpreter on a target machine, right? Next, let's go for the domain enumeration. Now, Once we have compromised the first machine in the target AD environment, we can go ahead and start with domain enumeration. Now, what does domain enumeration means? Getting an idea of different entities like users, groups, computers, their relationships, their privileges, etc., their ACLs, their group policies, their trusts, so that we can map an attack path. We can quickly draw some attack paths which we can follow to get to our target. Our target could be getting domain admin privileges, or our target could be to get access to a key piece of information, right? Now, please keep in mind that in the lab, we are going to limit our enumeration to a specific task, right? So our enumeration is going to be really, really quick, but in a real assessment, enumeration is the key to success. The more you enumerate, more are the chances of a successful attack. So in a real assessment, please spend more time on it. But in the lab, we are not going to do a lot of enumeration, right? So what are the tools which we are going to use for enumeration? My favorite, Microsoft's Active Directory module. So what is Microsoft's Active Directory module? It is the same module which is installed when you enable the Active Directory RSet on a domain controller or any other machine. So a common misconception is that you cannot use the Active Directory module without admin privileges or without installing the ADDS RSet. That's not true. So I maintain a mirror of the AD module. I make no changes to it. It is still Microsoft signed, even in my repository. And this is from actually a Server 2016 domain controller. So I'm just maintaining keeping a copy of it. Then we can also use PowerView or SharpView. Later on, we are also going to have a look at Bloodhound, all of them for enumeration, right? So the AD module and PowerView are PowerShell based tools. If you do not want to use PowerShell because of recent logging enhancements in PowerShell, then you can go for tools like SharpView, which are .NET tools, right? So let's have a look at what we can enumerate. Once again, we are going to be quite focused on the enumeration part. So we may like to have a look at the current domain, which we can go for using getNet domain from PowerView or getAD domain from the Active Directory module. All the commands in the darker font here are for PowerView, and the one in the lighter font in the Courier New font, they are for the Active Directory module. So if you want to enumerate the current domain, getNet domain, and getAD domain. If you want to get domain SID, domain controllers of the current domain, list of users in the current domains, getNet user from PowerView, or for a particular user, getNet user username file admin. This is for PowerView. For the Active Directory module, getAD user with all the properties and all the users, or all the properties of a particular user, right? We can also search for a particular string in a user's attributes. Let's say we want to have a look at the search term, or we want to have a look at the string built in the description field of all the users. We can use the first one from PowerView. If you want to use the Active Directory module for that, so we go for getAD user with the filter where description is like built. That is, it is not exactly built, but the string contains the word built. And then we want to have a look at it. If you want to get a list of computers in the current domain, we can use getNet computer from PowerView or getAD computer from the AD module. For groups, we can use getNet group for just the names of the group, or getAD group. For membership, we can use getNet group member for a particular group, or getAD group member for a particular group. If you want to get the group membership for a user, let's say if you want to know which group file admin user is a part of, then we can go for getNet group or getAD principal group membership, right? So once again, very specific enumeration, very limited to the tasks which we'll have at our hand. So Our task is to find a user in the cola.local domain with password in user description with the help of Active Directory module, PowerView, and SharpView. So a very interesting task. But before that, let's go for some basic enumeration, right? So what we are going to do, let's first use the AD module because that is my favorite, right? So there is an option in my repository. I maintain an option to actually use the AD module from memory, but it is fine to drop it onto the disk as well because it is a Microsoft signed module and actually used by administrators. So it is not going to be detected. So I've uploaded it to the C users file admin downloads directory of this machine, of our target machine. Let's start a PowerShell session there. The name of the machine is cola-file-srv, right? And I'm going to copy and paste some stuff here once again. Let me type this one out. This is quite easy. Right. So our zip archive, okay, I have some remnants from my testing. So we can use that. We will not use that, sorry. So let me remove this one. I'm leaving the sharpview.exe for now. Right now we have the zip archive. How do we expand the zip archive? Using the expand archive command. Right. Typo, and that is why I always like to paste the commands. So I'm now going to type it again. So I made a typo here. I included an A after X. So now you can see that we have the zip archive expanded. Now we need to import this module. First, we'll import the DLL within the module as a module, and then the Active Directory.psd1 module itself. Right, so now we have the Active Directory module loaded in the memory of our Meterpreter process, right? So let's enumerate the domain. So this is the information about our current domain, right? We are in a forest called cola.local, right? Which has what? That's the domain seed. That is the forest functional level, Windows 2016 domain. Once again, please keep in mind that there is no Windows 2019 forest functional level. There is just one domain controller. What else? There are no child domains. So we are sitting in the forest root. So it is a forest with just one domain, right? What else can we do here? Let's enumerate users. So these all are the users in our current domain. Let's go for computers. Please keep in mind that when you enumerate the computer objects, the result is based only on the computer objects, but not the actual computers. What does that mean? That means that when we run this and we get a list of computers here, because this is a lab setup right now and I do not want to inject any, I have not injected any computer objects. All of these are actual machines. But in a real assessment or in a real organization, you will find computer objects as well. That is, those objects do not actually are assigned or are used by a physical computer or a VM, but those are just objects, right? In fact, by default, a normal domain user can introduce directly up to 10 computer objects by default, right? What else do we have? let's go for group membership. So why am I still using PowerShell based tools? Because of filtering, right? It is super easy to filter stuff on the fly with PowerShell. I really like that, right? For example, if you want to have a look at just the names of the group in the domain, then we can use something like this. All of these are domain groups, not the local groups of this machine, right? Let's say I'm going to paste this one. Let's say we want to have a look at domain admins or the users who are member of the domain admin group. So we do that with the recursive parameter. What does the recursive parameter specify is if there is a group which is a member of the domain admins group, it shows you, recursively shows you the membership of that group as well, right? There is just one domain admin, the default domain administrator, which I wish was true for so many production environments, right? That is one of the major problems which I identify in enterprise environments. Just too many domain admins, which result in domain admin credentials being left on so many machines, right? One suggestion which I usually I see people going for is, or I've seen implemented, is renaming this administrator. Please don't do that, because even if you rename the default domain administrator, you cannot rename the well-known grid 500 of that domain administrator. So it is pointless to rename this. That holds true for the local administrator. You can and you should rename the local administrator, even especially if for some reason you are using that. But for the domain administrator, that doesn't make any difference, right? And let's, because we are running as file admin, let's check the membership of that user too. So file admin is a member of only one group, the domain users group, right? So you can see that this actually helps us in mapping a lot of things. For example, let's say file admin was a member of 5 more groups, and we have compromised file admin. So now we can go ahead and check if any of those groups has any interesting privileges. And by the virtue of membership, file admin will also have those privileges, right? Now coming back to our task, it was to find a user in the cola.local domain with password and user description with the help of multiple tools, right? So we had a look at the command actually. We just need to make some changes to it. So if I use this command, get AD user, and filter it on the basis of when description not equals null. That is, we want to have a look at only those users whose description contain at least something. That is, there is no null there. And then we would like to have a look at its description property. And once that is filtered out, we want to select only name and description from that. So if I run this, there are 4 users, 500, 501, and 502, administrator, guest, and KRBTGT. All of them have some description by default. And then there is a user called Sarah Hale, whose description contains a password looking string, right? Why is it password looking? It looks like a password, right? Contains a character, contains special characters. And this is actually, you may like to note that this is a nod to Sarah Hale, the lady who wrote the popular lamb rhyme, right? So, and that is why we have a user called Mary as well. So this is what the task was. We wanted to enumerate those users which may have the password, but it is not confirmed here that if it is a valid password. That is something which we are going to do later on, right? Let's go for Power View. So let's start a new PowerShell session. It is never a good idea to use the AD module and Power View or other enumeration modules in the same session, in my opinion. Sometimes there is an overlap in the function names which breaks both the tools. Now we can use Power View completely from memory here, and it is actually recommended, right? So let's paste it. Note that the download execute kernel looks quite similar to the one which we used for our Meterpreter session. We first execute the MZ bypass, then powerview.ps1. And I'm simply going to show you one command, right? Let's say if we run getnet user here, we'll get all the information about the users, right? I leave it to you to try and find how we can run a simple filter here, right? Or filter out only the description part. You can do it using the where object commanded from PowerShell, but I leave that to you, right? Finally, we found out actually that we already have sharp view here from my testing, right? Or we can upload it. We could always upload it again, but I'm not going to do that. So we can use sharp view as well. Please keep in mind that it is possible to run .NET assemblies from memory even in Metasploit. I tried it, but I could not make it very stable, so I'm not using that. Not a good idea in live demonstrations. So if I run this here, one drawback of using this is there is no filtering mechanism in command line as it is in case of PowerShell. But here you can see that we still get what we wanted, right? Or you can simply pipe it to, and let's say to a text file, get the text file and then run a grep on it. So it's up to you. But we found out a password looking string in description of the user Sarah. So that was our task for demo 3, right? Now, if we go to, so this was actually our domain enumeration part, right? Now, we are sort of jumping to the little movement part because file admin is already a local admin, right? I didn't want to touch much into this one. We will come back to this if we are going to, if we have time and we go to the bonus content, then we'll go for local privilege escalation on a machine called Cola SRV2, but not right now, right? Now, oops. The next step is to go for the lateral movement part, right? Once we have elevated access to at least one target machine, let's try to extract credentials from it. Now, there are so many places on a Windows machine from where you can actually extract credentials. From, for example, memory of the LSS process, LSS secrets, the SAM hive, credential vault. All of these definitely require the administrative privileges. You cannot extract credentials from them without having admin privileges, right? Unless you have modified the ACLs for, let's say, LSS secrets and SAM, but that's not the default behavior. Then there are files like unattend.xml and sysprep.xml. These are left by, and sysprep.infs in some cases, these are left by automation tools and mass scale out tools. So they might leave clear text credentials inside these files. They are usually accessible to non-admin users. Then auto logon credentials, these are also available to, usually available to non-admin users. Auto logon credentials are used especially for unattended logon, let's say for kiosks, right, where there is no one to log on. In those cases, these are used. So passwords and username and password, that is credentials, are stored in clear text on the target machine. Then the latest addition to this is PowerShell console history. So by default, there is a module by default on Windows machines. A module called PS readline is enabled. Now, what PS readline does, excuse me. So what PS readline does, it stores all the commands which you run in your PowerShell console, it saves them to a text file in console history.txt in the user's app data directory. And because it is stored in a file, it is reboot persistent, and unless you explicitly change the logging, the logging behavior, remove the PS readline module or disable logging, it logs all the commands, right? So if someone, let's say, is creating a PS credential object, and for that they are passing the password on the command line, there is a chance that you're going to find that in the PowerShell console history, right? But for now, we have Meterpreter as system, not as system. We can go to system. We have Meterpreter as file admin on Cola file SRV. So let's try to extract credentials from the memory of the else's process. Let's go for it. I think that is our next demo. We need to extract credentials from Cola file SRV using Kiwi extension of Meterpreter. Right, let's go for it. So this is the one which we have on the Cola file SRV. Right. So first, we are going to load the Kiwi extension, but before we do that, we have to actually disable Windows Defender, otherwise it detects it and our Meterpreter session will be lost. So for that, I'm going to use a built-in commandlet, set MP preference, disable real-time monitoring, which disables real-time monitoring. Please keep in mind that because we are targeting a server version and temper protection is not yet pushed to server versions, we can do that. If temper protection on Windows Defender is enabled, we cannot use this commandlet to disable Defender. But coming back to this, here we can, so we will. Okay, let me copy it again. I think copy was not correct. So, oh, there was a new line. Right, now let's exit from this. Right, oops. So I'm trying to keep the command prompt at the top so that it is better visible. Now let's load the Kiwi extension, which loads Mimikatz in memory of Meterpreter, and then the option creds all. So what the creds all command does, we need to get system, right? Let's now run creds all. And here you can see that we have the NTLM hash of the domain user called file admin, also the NTLM hash of the local administrator, and Cola file SRV. That's a machine account, right? So once we have this, so let's push this one to the background and go ahead with our discussion. So that was our task, right? We wanted to extract credentials from Cola file SRV using Kiwi extension. Now, once we have credentials, right now we have two sets of credentials. One is the clear text password, supposedly clear text password of the user Sarah, which we extracted from the user's description. And another one is the NTLM hash. Now let's discuss credential spring. So in credential spring attack, once we have access to some credentials, we try them across the Active Directory to check if we can access any other machine using those credentials. Now, what are credentials? When we talk about Active Directory, credentials could be clear text passwords, NTLM hashes, AES keys, and even TGTs. All of them we can consider credentials. So we have access to credentials of Sarah and file admin. Let's try them and check if we have access to any other machine in the network. So we are going to spray the credentials of Sarah and file admin to check our access on other machines. Right. So let's first go for the user Sarah. We are going to use an auxiliary module. Let me populate all the options first so that I need not open this clipboard again and again, right? So now what I'm doing here, I'm using a module called an auxiliary module from Metasploit, auxiliary scanner SMB login. As the name suggests, this tool tests for SMB logins. So we are setting up the following options from, there's a long list of options, which is this. So from all of them, we are populating the domain, which is Cola, which we identified, the SMB user, Sarah, which we are identified as well, and the password which we want to use. So this is the string which we extracted from the user's description, hoping to find out that this is actually a valid password and our hosts. Now, one very interesting thing here is, although because this is a domain user, we can always go only for the domain controller to check if it is a valid user. But because we are using SMB login, if this user is administrator on other machines, that will stand out. So therefore, we use all the machine names here, and let's run it. So this user Sarah doesn't seem to be an administrator on any machine, but this is a valid password, which is very good, right? We can also do that if you don't want to use this using Metasploit or want a faster solution. We can do the same stuff with CrackMapExec, a very popular tool. So what we are doing here, we are telling CrackMapExec to test on the SMB protocol on all these machines, the domain to be Cola, the username to be Sarah, and password is the string which we discovered. So let's run this. And as you can see here, we actually successfully can authenticate to these machines. This means the credentials of Sarah are valid ones, right? Now, what we can do next is, I think do I have the commands for the file admin user? Not yet. We'll do that later on. So what we found out here was that in both using CrackMapExec and this auxiliary module is the credentials of Sarah, which we found in cleartext, are actually credentials. That is, this string is actually a password. Now, but we do not have administrator privileges on any of the machines. So what can we do next? At this time, if it was not a workshop, if it was a real assessment, what we would need to do, we would go back to our Nmap scan results and check what other services are listening on the network. Because probably this user, if the user and name and password combination does not have elevated privileges on one of the services, it actually may have elevated privileges on other services on a machine. So that is what we are going to do. We found out that in our Nmap scan that WinRM, that is port 5985, is open on almost all the machines. So let's try the WinRM login auxiliary module from Metasploit. I'm going to paste the commands. Let's try that module to check if this user has any interesting privileges there, right? So what we are doing here, we are using the auxiliary scanner WinRM login module. Once again, we are setting the domain to Cola, username to Sarah, password to the string, and these are our hosts. Please keep in mind that by default, a user must have administrative privileges to log in using WinRM, right? Unless the user has some other group memberships, or the configuration on the target machine is not changed. By default, a user must have administrative privileges. Sorry. So let's run this. So as you can see that on the machine 2.35, actually on port 5985, which is the WinRM port or PowerShell remoting port, it was possible for our user or the Sarah user to log in, which is fantastic, right? This means that either there is some configuration change on 2.35, or this user is a member of the remote managers group, a local group which allows access using WinRM without having administrative privileges, right? So we have done that. Now, before we go ahead, let's spend a bit more time on PowerShell remoting. So PowerShell remoting, as we saw, listens on port 5985 and 5986 with SSL. It is enabled by default on Windows Server OS, not the client OSs. All the server OSs post Server 2012, right? With an exception added in the Windows Firewall, right? So you will find it by default, if it is not explicitly blocked, you will find it by default listening on port 5985 on a Windows Server machine, which is newer than Server 2012. It is the recommended way of managing Windows servers, and therefore it is very useful for attackers. Anything which is useful for managing a machine is also useful for attackers, right? Now, there are three main commandlets which we can use to use PowerShell remoting. New PS session, to create a PS session or a PowerShell remoting session to a machine, to a remote machine, which by default needs admin privileges. Enter PS session, to interact with the session created in new PS session in a one-to-one way, that is one machine at a time. And invoke command, which can be used to connect to multiple machines parallelly using PowerShell remoting. So this is what this is how we can interact with PowerShell remoting, right? We want to use, or we want to get a Metropreter session on Cola SRv2 by using PowerShell remoting from our Metropreter on the file SRV, right? So what is Cola SRv2? Cola SRv2 is actually this machine. As I said, I skipped a bit of enumeration and leave it to you. Otherwise, you would know that. So 2.35 is our Cola SRv2 machine, right? So what we want to do is, we identified here that using WinRM, the user Sarah has access to Cola SRv2. So we are going to use those privileges to get a Metropreter session on Cola SRv2 as well, right? So what, do we have any session right now? We have a session as system on Cola file SRV. So let's interact with it. So what I did here was, recall that before running the creds all command, I ran get system. That is why it was visible that we have a Metropreter with system privileges on Cola file SRV. But I reverted using revert to self command to Cola file admin, right? Because it was token impersonation, we just simply let that token away. Now, to be able to run PowerShell commands, PowerShell remoting commands, we can either drop to the PowerShell or we can use the PowerShell extension. So let's use the PowerShell extension. We've already seen dropping to shell and then PowerShell already. So let's try this one now. right? Okay, before this, actually, I have to start a listener. Let's background this one. So before we can launch a command to run a meterpreter or to get a meterpreter, we need to run a listener. So here we have a listener on port 4444 already. So let's start a new one. So what we are doing here, we are using the multi-handler or listener, the same payload with, like the one which we used earlier, the same listen host, the L host, that is the payload connects back to us. But in place of the default 4444, we are using 4443 here so that we can run another listener. And we are using -J and -Z or -Z. So exploit -J means that it keeps running as a job, and -Z means it keeps running in the background. That is, as soon as the meterpreter session opens, you will not interact with it, but it will keep running in the background, right? Now we go ahead and we can generate a payload here using MSF Venom, as we did earlier. So I'm not going to run it. I'm just going to show you the command. It's exactly the same as we used earlier. Only difference is here we are using the L port 4443 and saving it to another file so that we do not upload, do not overwrite our previous payload, right? So once that is done, we actually have the payload 4443 ready for us. That's the one which we are going to use. So once we have that ready, now we can go to, once again, we have just one session right now on Cola file SRV. We are going to use that to run a command which runs a meterpreter session, which connects back to 2.1 on 4443. Right, so let's run a PowerShell shell. Oops. I want to clear this so that the prompt is on the top. Right, so the command which we are going to use is this one. So what are we doing here? Let's have a look at these commands. These are multiple commands. This is one command. We are actually trying to create a PS credential object. So a PS credential object needs the password converted to secure string. That is what we are doing here. We are converting the password to a secure string, and here we are creating the PS credential object. Yeah. Right, we are passing the username Sarah here and the password variable, which is this one, right? Now using that PS credential object, which we are storing in the variable $creds, using that PS credential, that is using those credentials, we create a new session, a new PowerShell remoting session to Cola SRV2. Once we have that session there, we use the invoke command built in commandlet to run our one-liner download execute cradle, right? So let's try this now. If I run this, we'll see that we have a connect back from 2.35. We have connect back to 4443, right? Let's background this one using Control-Z and background our previous meterpreter session. If we run the sessions command right now, we'll see that we have two meterpreter sessions. The second one is the one which we opened here, right? So that is our task. That is what we wanted to do, right? We have the privileges of user Cola Sarah here. And I think that was our task here. Now, another interesting lateral movement technique is ACL attacks. Now, there is an access control model in Active Directory, which enables control on the ability of a process to access objects and other resources in Active Directory. So an object has access tokens, right? Now, that access token has security context of a process. What is the security context of the process? Its identity and privileges of the user, with whose privileges the process is running. Now that access token is presented to the target object. Now target object has different security descriptors, which contains SID, the identifier of the owner, a list called a discretionary ACL, which is a list of permissions, and another one called system ACL or cycle, which contains the list of auditing, right? So every list is, of course, made up of different entries. That's why it's called a list. Now, every list in every ACL in Active Directory is made up of different ACEs or access control entries. Now, each ACE corresponds to an individual permission or audit access. In case of DACL, it defines the permissions of a principal or a user or a group or a computer or whatsoever, what permissions they have on that object, right? So that actually controls your access to every object. For example, why are domain admins? I mean, why do they have such big permissions or administrative permissions on all the machines, or sorry, on most of the objects in the domain? That is why, because domain admins have an entry on each ACL, which provides them almost full control, right? So if you would like to have a look at that, and that is why I'm really liking this victim view, right? Let's have a look at that. So here, if we go to the domain controller here, and let's have a look at the ACL of one of the popular groups, or any group, let's say. Oops, not the server manager, like this. So what are we looking at is how ACLs actually look like. Let's go for, let's go for the ACL of the domain admins group itself, right? So this is the DACL. This is the access control list. This one is SACL under the auditing tab. The one under the permissions tab is the DACL, which defines permissions for separate principal, right? For example, domain admins, or let's say the system principal, is allowed to have full control over the domain admins, right? This is what these are ACEs, each individual entries and ACE, and all of these entries make this ACL or the list. Now, why domain admins are admins? Let's open up some other user. Let's look for the user file admin, the one which we have access to. If we have a look at its ACL, we will find that the domain admins have full control over it. The system has full control over it. So what does that mean? This is what defines administration, or this is what defines privileges. If we add a user here and it has full control, let's say, over this particular user, then that user would have admin equivalent privileges on this particular user. That is what domain admin, that is why domain admins have so high privileges, right? So if we go back to our attacking machine now, no, we were on the slides actually, I think. So that's what ACLs look like in GUI. Now, how do we enumerate ACLs without having access to a GUI, right? We can use Power View, for example, commands from Power View like get object ACL and invoke get object ACL can be used to list ACLs associated with a specified object. it contains one very interesting function called invoke ACL scanner. What invoke ACL scanner does, it extracts all the ACLs from the target domain and lists only those where there are some interesting permissions like modify or write, etc. We can also enumerate ACLs using Active Directory module, but it would not be possible for us to resolve GUIDs. But if you really want to use only the AD module, then you can use the built-in get ACL. So you import the Active Directory module, and then, so when you import the Active Directory module, it loads a pseudo PS object called AD:. Then you can use something like this to list the ACLs, right? So you might have guessed where this is going. Now we want to enumerate ACLs in cola.local where file admin has write or modify permissions. Once we have identified that, we need to abuse the permissions to compromise another target machine, right? Now, what are the permissions which we may like to attack? So there are so many Active Directory permissions. Some of the more interesting ones are this. So there are two types. Let's say for the generic and control rights, we have generic all, which is full control. Then there is generic write, where we can write any property of the object. Then we have specific write property. So how write property can be useful for an attacker? Let's say we modify SPN of a user object, then we can curb roast the user. That's how write property is used. Write decl is to modify the ACL for the object. So if we have the write decl control write on an object, we can modify its ACL and let's say allow us full control over it, right? Admin ST holder, those of you who know about it, I will not explain it. The admin ST holder is a very good example. If you have write decl permissions over admin ST holder, you basically can have, let's say, domain admin privileges at your will, right? Now there are extended rights. There's a typo here, sorry. Now there are extended rights. Some of the most popular and useful ones, one is the DS replication get changes, a set of rights. There are 3 rights. These are the DC sync rights. If your user has those 3 rights, you can actually run the DC sync attack without having domain admin privileges. Then there is another very interesting extended right, user force change password. If you have user force change password right on a user, you can reset the user's password without knowing the previous one, right? So these are some of the ones which are very interesting for attackers. Let's start enumerating them. So let's go for power view here, for example. But let's go for Bloodhound. So we can extract this using, let me try with power view first. Let's do it with power view first. Let me push this to the background. I'm going to use the one where we have Cola file admin privileges. So let's load power view here. Right, and let's now run the invoke ACL scanner here. So it may take some time because it goes through all the ACLs. Meanwhile, we can start Bloodhound. So let me start the Neo4j console first. So Neo4j console, which starts the graph DB used by Bloodhound. Meanwhile, it is starting. We start Bloodhound. So let's use this. So we have not executed the ingesters here, so we need to do that actually. So here you can see that in case of Power BI, we found out that on the user SQL access. So here is how we can read ACEs or ACLs, ACEs, that's better. That is a single entry from the command line. So object DN represents the object on which we run the command, that is here, or on which the, for which the ACE is for. So this ACE is for the object SQL access. On SQL access identity reference, file admin has some rights. What rights? That is represented by Active Directory rights, generic all. So what this ACE tells us is on SQL access, file admin has generic all rights. That is full control, which is awesome. We can do the same thing with Bloodhound as well. Let me do that quickly because we have some more interesting things to do. So we have PowerShell here, and I'm going to run Bloodhound's ingester in memory. Let's run that. We have loaded it in memory, and now we are going to run it. So it was quite fast because ours is a very tiny domain. Oh, I wrote in the system 32 directory, so need to keep that in mind. So let's download our zip archive. Right. Now we are going to go to Bloodhound and upload this. I think that was the one from my testing, and this is the fresh one. As you can see that our database is now populated, right? Our task was to look for ACLs where file admin has write or modify permissions. So let's search for file admin. And let's have a look at its first degree object control for ACL permissions. So file admin has generic all on SQL access, right? That is something which we found out using Bloodhound as well. If you try the labs, make sure that you spend enough time with Bloodhound. It is a very useful tool, especially for blue teamers and penetration testers, right? One more thing which we are going to use later on is the shortest path to unconstrained delegation systems. As you can see that it is here. Because I'm going to stop Bloodhound, it's a bit more memory intensive to my liking. So let's stop it and stop the new 4G database too, right? So we identified that file admin has full control over SQL access user. Well, let's abuse that, right? So we go to our session as file admin. We drop to PowerShell session. Downloads. Okay. I forgot a CD here. So we download it. We go to the downloads directory. We have the AD module there because we previously downloaded it. Let me check that. Yes, it is still there. Let's quickly import it. And because we have the generic all permission, over a user, the best thing which we can do is to reset its password without, there is no need to know the user's previous password. So we are going to use this command from the AD module, set AD account password for the user SQL access. We want to reset it, and this is the new password. So let me run the command, and hopefully it was successful. Now we need to check if it was actually successful. How? Once again, by using the credential spring tools which we have used earlier, right? So let's quickly use the SMB login, which we used earlier as well. SMB login module, the SMB domain is Cola. Username is now SQL Access, and this is the password at 123, which we set using our file admin privileges. And this is the machine we want to try it out. Let's run it. Sweet, isn't it? So we have access to 2.169 as administrator, right? So we simply reset the password of a domain user who is an administrator on a machine because of misconfigured ACLs. And that is why ACL misconfiguration is a huge issue and must be resolved, right? You must audit them to keep your environment safe. Now we can use tools from the in-packet library. We are going to use the the SMB exec module to get a shell, a semi-interactive shell, as in-packet calls it, on 2.169. So 2.169 is Scholar reports, right? And we have the privileges of system. That is, it is confirmed that SQL Access is an administrator on the target machine, right? And finally, let's get a meterpreter as well there. So once again, we can actually kill all the remaining sessions. That is what my notes tell me, because we do not need other sessions now. But don't do this in any real world scenario. You never know when you might need a session. So I kill all other sessions and start my listener again. I'm not going to explain the listener commands one more time because we've been using it a lot. And here we are going to use a trusted but that's not the one which, that's the one, 2.169 as well. It is the one from 2.169. And we have a meterpreter session ID 3, which once again is running with system privileges, right? Very interesting. So we have now compromised a couple of, I think 3 machines in the target environment. Now is the time to look for or go for domain privilege escalation, right? So what we are going to use for domain privilege escalation is a delegation issue. So Kerberos delegation was introduced in Windows Server 2003 to allow, and this is a textbook definition, reuse the end user credentials to access resources hosted on a different server, right? So this was typically useful in multi-tier service or applications where Kerberos double hop is or was required. For example, user authenticates to a web server and web server makes requests to a database server. Now the web server must have a way to authenticate to the database server as the user. That is, it must have the capability to impersonate the user, and to provide it that capability, delegation was introduced, right? So delegation is, do I have another one for unconstrained delegation? No. So what happens in the case of normal delegation is, let's say a user authenticates to the DC, right? So step 1, user provides the credentials. Step 2, the DC returns a TGT, a ticket granting ticket to the user, which authenticates the user. User returns the TGT and requests a TGS. That is step 3, requests a TGS for the web server. Step 4, the DC validates the TGT and provides the TGS. This is fine. Now pay close attention now. Step 5, the user sends the TGT and the TGS to the web server. This is unconstrained delegation. That is, if web server service account has unconstrained delegation enabled, the user's TGS will have its TGT encapsulated inside it, and when the web server opens up the TGS, it will get the user's TGT too, right? Now in step 6, with the help of user's TGT, the web server authenticates to the DC TGT, provides the TGT to the DC, the TG, and requests a TGS for the database server. Now the DC validates the request by looking at the TGT and provides a TGS to the web server for database server, but the TGS is for the user's account. That is, in step 7, when the web server presents the TGS to the database server, it has successfully impersonated the user here. This is what unconstrained delegation is, right? You can read this reference slide later on. I'm not able to get through it. There's no need for that. And this is something which I explained in the diagram. When unconstrained delegation is set for a particular service account, it has the capability, or the DC provides the capability, that whatever or whoever user connects to that particular machine where unconstrained delegation is enabled, the user's TGT is available with the machine, and the machine can authenticate to any user in the domain, any machine in the domain as that user. This means that if this user in our diagram was a domain admin and it authenticates to the web server service account will have the capability to authenticate to any service in the domain as the domain administrator. That means that if the web server is compromised, someone has administrative access to the web server, they can get the domain admin privileges, right? Now, how do we abuse unconstrained delegation? We enumerate and identify computers in the target AD with unconstrained delegation enabled, step 1. Step 2, we compromise that computer. Keep in mind that when we run this attack from Linux, there are some extra steps included after the compromise. Now, once we have compromised the computer with unconstrained delegation enabled, we force a high privilege account like a domain admin or DC machine account to connect to the computer. In normal circumstances, we cannot force a domain admin to connect to such a machine, but we can force a DC machine account thanks to the printer bug, right? We can actually trick the print spooler service so that it forces the DC machine account to authenticate to us. Now, if we have that connection, we can extract TGT from LSS of the machine where unconstrained delegation is enabled using Mimikatz or any other tool, right? Once we extract the TGT, we inject it on our own machine, our attacker machine, and profit, right? That's how we abuse unconstrained delegation, and that is what we are going to do in our next demo. So now we need to find a computer in Cola domain where unconstrained delegation is enabled, right? So if you were paying attention, we found that out using Bloodhound, right? Cola reports was that machine, but we'll do that again. And then we abuse that to compromise the domain controller machine account. That is what we are going to do. So let's do that. Let's first enumerate, this time using in-packet. Let's enumerate if we have any machine with unconstrained delegation in the cola.local domain, right? As you can see that we have cola reports is a machine which has unconstrained delegation enabled, right? So first we need to extract the credentials of cola reports. So that this is a Meterpreter session on that machine. So let's drop to a PowerShell session first so that we can run set np preference to disable Windows Defender there. Once we have done that, we fall back to our Meterpreter session and use the Kiwi extension, that is Mimikatz, to run a command here. Secu LSA E keys, right? If I run this, we get the credentials for the cola reports, right? That's the AES key, that's the NTLM hash. Please note that you may have different AES keys, right? For the same account, only one of them is one of these works. But we take a note of these and we leave this as it is. Now we can use the KRB RelayX master tool to abuse unconstrained delegation from the Linux machine. reports machine, and so that SPN actually points to our machine, our attacking machine, because our machine is not part of the domain, right? So let's do that. So what this command does, it adds an SPN for host service. It adds an SPN srv11.cola.local. It points to our own machine, and we add an additional host name in the properties of Cola reports so that it points to our current machine, right? So we run this. So it was successful, right? Let's verify that. And once again, we can verify if we want from the Meterpreter session, but we are going to use once again the victim view for that, right? If we open up a PowerShell session on the DC, let's have a look at let me increase the font size a bit. Okay, I think I have to type it out. Get the computer. Reports, and I want to look at the following properties: service principal names and MSDS additional DNS host name, right? So our additional DNS host name for Cola reports right now is srv11.cola.local, and as here you can see that additional service principal names have also been added, right? So this is what our add SPN command did. Now, what is missing on the target on Cola reports right now is that for our srv11.local, there is no DNS entry. That is, the domain controller will not know what is the IP address of srv11.cola.local. So that is something which we are going to do now. Using the credentials which we extracted previously, we are going to now add 192.168.2.1, that is the IP address of our attacking machine. That so srv11.cola.local will resolve to our attacking machine's IP. That is what we are doing. Any non-privileged user in a domain can actually add DNS entries. So we are making use of that, right? Once again, what we did, we created an additional DNS hostname of additional, that's why here it is additional DNS hostname of srv11. Previously also created a service principal name. And now we are creating a DNS record which tells the DC or any other machine that srv11.cola.local is actually 192.168.2.1, that is our current machine, right? Now finally, we using the AES-256 keys, we have been using NTLM hash up to now, using AES-256 keys, we are going to start the KRB Relay X tool, which actually will help us in capturing the TGT of DC dollar, of Cola DC dollar, the domain controller machine account. So let's run this. You can ignore this HTTP error. So the useful one for this one is not useful for us. So you can ignore this error, right? And now in another terminal, we can go to the KRB Relay X master, and now we are going to trigger the printer bug, that is use the print spooler service to force connect the domain controller to the machine which we control. And here you can see that we are telling the DC to connect to srv11.cola.local, which points to 192.168.2.1, which is our current machine. It says RPC server unavailable. Let's try again. Do we have connect back here. No, we don't. Okay. If we get an access denied here, that would mean that it works. Okay. Let me try with the other AES key as well. So we run this. Okay, so this time we have an access denied, and you will see that okay, this time it says that the key is incorrect. Let me try again then with the previous one. So we start the listener again, and we run this one more time. And once again says access denied, and it got the ticket. So it takes some time actually for probably the resolution to take place, right? Now, once we have the ticket, we export it to a variable. Right. And then we can use the secrets.dump.py to extract all the secrets from the DC or run the DC sync attack, right? This is what the DC sync attacks look like. You can see that we have access to the hash of the administrator of the KRBTGT so that we can create golden tickets. Then those are NTLM hashes. Then we have the AES keys, right? So that was how we got our domain admin privileges. Now, finally, we can actually persist with the help of, so we have the domain admin privileges, and how do we persist with those privileges? That is something which we can do with the help of a golden ticket attack. So this is the normal workflow of Kerberos. This is what happens when you authenticate to a machine. You want to access a service. Once you log into your client and you want to access this application server, its password is converted to NTLM hash. A timestamp is encrypted with the hash, and it is sent to the KDC, the Key Distribution Center, a service on the domain controller. The domain controller responds to the TGT, which is encrypted and signed with the hash of a special account called the KRBTGT account. Now, the client does not have the hash of that KRBTGT account, so it responds with the TGT and presents it to the DC. The only validation, and this is very important in this case, the only validation which the DC does is if it can decrypt the TGT, it assumes whatever you have written inside the TGT is correct. There is no other validation, at least for 20 minutes. So once the DC responds, decrypts the TGT, it responds with the TGS, which is encrypted with the target services NTLM hash. And then the client presents that TGS to the application server or the service and gets access to the service, right? Now, in step 3, the only validation which the DC does is if it can decrypt the TGT. The TGT is encrypted with the NTLM hash of the KRBTGT account. What does that mean? That means that if we compromise the hash, or that is if we extract the hash of the KRBTGT account, we can forge whatever TGT we want, we can write whatever we want inside it, and the DC will validate it, right? That is, we focus on step 3 here. So do we have the AES key or NTLM hash of the KRBTGT account here? Yes, we do have. Here you can see that we have the AES keys. And here we have the NTLM hash. Now, This provides persistence because usually the credentials or the password of the Kirby TGT account is not changed, it is not rolled, right? Organizations do not usually touch this account. And I have personally seen environments where this is not changed for years. So what would that mean? That means that you simply need to compromise that target environment just once. As soon as you have the Kirby TGT account hash, you can come back later on 6 months, 1 year down the line, and if the Kirby TGT account's password is not changed at least twice, then you will have your domain admin privileges back again instantly, right? And we don't even need a domain join or a Windows machine for that, right? We can do that using Impacket library right from, even from a Linux machine, right? So let's quickly have a look at that. That would be the last thing which we go for, because we still need to discuss defenses. So using the ticketer utility from Impacket, right? We are using the AES key of the Kirby TGT account. Let's run this. Right, the golden ticket is saved in administrator.ccache. We export that to a variable. And then we can use SMB exec without specifying a password. We explicitly tell SMB exec to use no pass. And we will have system privileges on the DC. So that was slow, otherwise, so the timing didn't fit in, right? So we have system privileges on the domain controller, right? And I know that there would be an itch for a meterpreter session here. So we have a listener running on 4443 and using our download execute Cradle. We can actually get a meterpreter session on the domain controller, right? It's a bit slow, so my timing is, my punches are not landing correctly. So we have a meterpreter with system level privileges on the DC. So this actually completes our attack part, right? So, and I hope you liked it. So if you're scared enough now, if you think that you need to take Active Directory security seriously, let's discuss detection and defense. So I have divided the detection and defense section in these sub-modules. First, we'll have a quick look, and all of these are quick looks actually, how to protect and limit domain admins, then isolate administrative workstations, then secure local administrators, then how to use time-bound and just enough administration, and finally, to isolate administrators in a separate forest and breach containment using tiers and ESAE. First, let's have a look at the protection of how to protect and limit domain admins. So the first one is obviously to reduce the number of domain admins in your environment. That is something which I said when we enumerated the domain admin membership in our lab as well, right? That is something, I mean, that is not going to happen in any enterprise environment. Very hard to have just one domain admin, but if we reduce the number of domain admins, that's awesome. Also, do not allow or limit your domain admin logins to any other machine than the domain controller. But if for some reason a domain admin login is required on other machines, there should be absolutely no other administrator, not even a local administrator on that machine, right? Then also, sorry. Also try to never run a service with the DA. Credential theft protections like protected users and credential guard cannot protect you against credentials used for service account, because service account credentials are not stored in LSS. Finally, also set account is sensitive and cannot be delegated for DAs and probably DCs as well, probably, right? That needs testing because that actually may break some trusts, right? This is how you protect and limit your domain admins. Now, one very interesting thing is protected users group, which was introduced in Server 2012. And this is not protected groups. Protected groups is something different, which is protected by admin ST holder. Protected users group is introduced for, as the textbook says, better protection against credential theft. How? It does not cache credentials of users who are member of this group in insecure ways. So what are insecure ways? You cannot use CredSSP or WDigest for authentication for a user who's added to this group. NTLM hash is not cached. Kerberos does not use DES or RC4 keys. So Kerberosting sort of stuff would be hard, right? And if the domain functional level is Server 2012 R2, then there is no NTLM authentication, no DES or RC4 keys, no delegation, that is no constrained or unconstrained delegation, and no renewal of TGT beyond initial 4-hour lifetime, 4-hour lifetime. That is hard-coded and unconfigurable, which attacks, which stops credential replay attacks. But there are some cons as well. For example, all domain controllers to be have at least Server 2008 or later. Microsoft does not recommend to add all DAs and EAs to this group without testing the potential impact of logout. So you may like to probably have an emergency domain admin who is not used otherwise and is not part of the protected users group, right? Another problem is, which although does not apply to regular users, is there is no cache logon. That is, if a user connects is a mobile user and cannot connect to the domain to the corporate domain network, then the user would probably will not be able to sign on. But that generally does not apply to domain admins. I mean, why would you have domain admin privileges to give domain admin privileges to your finance guys, right? Right. Another module is isolating administrative workstations. This can be achieved using privileged administrative workstations. So the idea is quite simple. You have your administrators, those who have access to high value targets like say domain admins and domain controllers. They have a separate hardened workstation for sensitive tasks and another one for other things, which I always like to call Facebook, right? So you have one machine or one workstation for accessing jump servers or domain controllers, etc., and another machine for Facebook, right? Now those machines ideally should be separate hardware, but there are some different strategies which you can use. For example, if you cannot, if you do not have enough budget, or your administrators are not agreeing to carry two separate hardware, or if you are afraid that if your PAWs are laptops and someone may simply snatch them from your administrators while they're commuting, then you can have a VM. So you have a workstation which is a PAW, and then there is a VM inside it for Facebook, that is for user tasks. So that's another strategy. One more hardening is to secure local administrators. So this is still very prevalent, unfortunately. That is, there would be same local administrator password for all the machines or many machines in a network. And if even one of the machines is compromised, the complete network is compromised. So LAPS, local administrator password solution, solves that to much extent. When you implement this in a forest, there are two new attributes. It modifies the schema. And there are two new attributes which are added to computer objects, MS MCS ADM PWD and MS MCS ADM PWD expiration time. So MS MCS ADM PWD, this stores the clear text password, right? This stores the clear text password. Please keep that in mind. Labs stores the password in Active Directory object property in clear text. Although that sounds stupid, but the reasoning is pretty solid. So what Microsoft's reasoning for that is, yes, the password is stored in clear text, but the access to read it is that rests with, by default, only the domain administrators and the users you add, right? So it is not like that everyone can come in and read the clear text passwords, right? But one thing which I would like to add here is, with careful enumeration, we can actually retrieve a list of users who can access the clear text password, right? That provides us an attractive list of targets. So still, if you ask me, I suggest to use labs. Much better than having a same password or passwords attributing by account for all the machines in the domain, right? Another module which we discussed was time-bound administration. So just-in-time or JIT is an administration which provides the ability to grant time-bound administrative access on per request basis. That is, a user must request that, okay, I need administrative privilege for this particular task for an hour. Please provide me that. So for that, so in case of Azure, this is provided using self-serve portal. That is, user can raise a request and then they can have the request. In case of on-prem Active Directory, which we are discussing right now, you can use the add AD group members built-in commandlet, and then there is a member time to live option there, which can be used. Please note that privileged access management feature, PAM, needs to be enabled. So JIT, JEA are part of PAM. Now what is JEA? Just enough administration. This provides role-based access control for PowerShell-based remote delegate administration. So what does that mean? That means that using JEA, even non-admin users, so we are trying to limit the number of administrators and the time period where for which they have those administrative privileges. So with JEA, non-admin users can connect remotely to machines for doing specific administrative tasks. For example, we can control what command a user will run. Let's say the user can run get service, and even what particular parameter or option which can be used. So JEA provides that much control. Even for the domain controllers, we can provide a user local administrative access even on the domain controller, but what the user will be capable of is using just one particular commandlet with the options which is specified. Also, all the JEA endpoints have PowerShell transcription and logging enabled. Whatever someone does using JEA endpoints is logged. Finally, let's have a look at the Active Directory administrative tier model. So this composes of 3 levels only for administrative accounts. Normal users are not considered in this. Tier 0 is accounts, groups, and computers, which have privileges across the enterprise, like domain controllers, enterprise admins, domain admins. Tier 1 are accounts, groups, and computers, which have access to resources having significant amount of business value, right? Then tier 2 comes to administrator accounts, which have administrator control of significant amount of business value. Let's say user workstations and devices. Now between these 3 tiers, there are 2 types of restrictions: control restrictions, that is what admins control, and logon restrictions, where admins can log on to. So in control restrictions, tier 0 can control which, for example, administrators from tier 0 can move a machine to tier 1, who in turn can move a machine to tier 2, but the other way around would not be possible. Now, logon restrictions are just opposite of that. No user from tier 0 can log on to tier 1. If they cannot log on, then the chances of their credentials being compromised are out of the picture. Similarly, so no one from tier 1 can log on to workstations on tier 2. Now, if we take all these PAM related to GIT and GEA, we take tiers, etc. And we want to create an environment of which, and we take PAWs, etc., which is secure for administration. Then we reach the ESAE, Enhanced Security Admin Environment, or the famous Red Forest. Now, what ESAE or Red Forest is, it is a dedicated administrative or best-in forest for managing critical assets like administrative users, groups, computers, etc. in tier 0. Now, because a forest is a security boundary, this provides enhanced security controls. What security controls? For example, selective authentication, right? There is a selective authentication to the best-in forest right here, which enables stricter security controls on logon of users from non-administrative forests. Now, also, PAM trust can be or is established between best-in and production forest. So if we use PAM trust, using the shadow principles, administrators from the admin forest can actually go and complete their work in tier 0 of the production forest without having to ever authenticate to any domain controller here. So if they will not authenticate to the domain controller or any other machine, there is no chance of their credential being stolen from them, right? Now, some monitoring tips for golden ticket. Unfortunately, for golden ticket, only 4624 and 4672 are logged. So 4624 is account logon, 4672 is admin logon. But please keep in mind that if you get a 4672 on your domain controller from a machine where your domain admins usually do not log on from, then that should be an alert. Also, you can do traffic analysis of Kerberos traffic for unusual TGS request messages. This is something which Microsoft's Advanced Threat Analytics do. Then for ACL attacks, unfortunately, by default, there is no logging enabled. If you enable logging, then you will get these events. You can use the AD ACL scanner, which is a very useful tool for scanning ACLs. It's a free and open source tool, so you can use that as well. Make sure that you use Windows Defender Credential Guard or Credential Guard, because it helps in protecting against many attacks. Although Mimikatz can bypass it, it's still worth it, right? But please keep in mind that Credential Guard cannot protect against credentials stored in SAM and service account, right? That is local users and those accounts which are used as service account. You may also like to use application whitelisting in form of either App Locker or Device Guard or both. So Device Guard is much more advanced than App Locker, but it does not provide per user or group basis policies. For us, relevant to this discussion, because we are in user mode, is the UMCI, the user mode code integrity. So user mode code integrity makes sure that only known good code is executed, like let's say Microsoft signed binaries, right? So once again, even WDAC or Device Guard, that can be bypassed. There are abuses. There are known Microsoft signed binaries which can be abused. But this is super, super useful for reducing your attack surface, right? And if not anything else, you can always run it in the audit mode. So you will have very, very intelligent logs of what is being executed on your machines. You do not use them in the blocking mode, even the audit mode would be fine, right? So that would be all for this attacking and defending Active Directory for Red Blue teams. Thank you very much. You can visit pentestacademy.com for our courses. Once again, if you want to use the challenge lab using the workshop, you go and sign up here. And you can visit our other cyber ranges from this link, right? So that would be all from me. Thank you very much. Over to you, Mohammed.
Hi, how are you?